Hello friends, in this lecture we will cover the next type of sensor, that is biosensor. Now the learning outcomes. Now after studying this topic, student will be able to understand first what is biosensor, then the block diagram of biosensor and the applications of biosensors. Now what is biosensor? A biosensor is a device that measures the biological or chemical reactions by generating the signals which are proportional to the concentration of analyte in the reaction, and it also includes the combinations of the biological detecting elements like sensor systems and a transducer. Now let's see the block diagram of the biosensor. Now, if you see the block diagram, then it basically consists of the main three components, that is analyte, then the bioreceptor and the transducer. Now, what is analyte? Now, analyte in analyte, a substance of interest that needs the detection. Now, for this instant, glucose is an analyte, and in a biosensor designed to detect the glucose. Now, bioreceptor. Now, what is bioreceptor? A molecule that specifically recognizes the analyte is known as the bioreceptor. The enzymes or cells, the or aptamers or DNA and antibodies are the some examples of the bioreceptors. And the process of signal generation, that is in the form of light or heat or pH or the charge or mass change, etc. Upon the interaction of the bioreceptor with the analyte, it's termed as an biorecognition. Now what is transducer? Now in this block diagram, a transducer in a biosensor, the role of transducer is to convert the biorecognition event into a measurable signal. And the biosensors are employed in applications such as disease monitoring, then the drug discovery and the detection of pollutants, then disease causing microorganisms and markers that are indicators of the disease in bodily fluids, that is blood or urine or saliva or sweat. And finally the output of your transducer is applied to the signal processing unit. Then signal processing unit will process that particular signal which is received from the transducer. Then the output of your signal processing unit is applied to the display, and finally you will get the result on the display. And if you see the means the combination of your bioreceptor or transducer or signal processing is nothing but your biosensor. Now, which are the different types of biosensors? Now, biosensors can be of following types, that is electrochemical biosensors or amperometric biosensors or potentiometric biosensors, then the physical biosensors, then the piezoelectric biosensors, then the optical biosensors and wearable biosensors. These are the various types of the biosensors. Now, which are the different applications of biosensors? Now, first, biosensors can be used in medicines and health. Then the biosensors can be used in industry, then for pollution control, then in military applications, then in food industry. In these various areas which we can use the biosensors. Now let's see one application of the biosensor, that is blood glucose biosensor. Now the blood glucose biosensors are used widely throughout the world for the diabetic patients. And the blood glucose blood glucose biosensors, the enzyme glucose oxide catalyzes the oxidation of D-glucose according to the following reaction. Now which reaction? That is D-glucose plus O2 plus H2O2 minus H2O2 plus D-gluconic acid. Now three means are available for measuring the glucose concentration with the electrochemical transducers. Now first, that is the fall in oxygen, that is O2, as the reaction proceeds. Then the second, that is the production of H2O2, and the third, the change in the pH with the production of D-gluconic acid. and a typical sensor that uses the electrochemical transducer to measure the glucose concentration based on the change on O2 in glucose oxide catalyzed reaction. Now here the figure shows the differential biosensors to measure the glucose using two O2 electrodes. Now one electrode is used to measure the ambient of O2 level to interrupt the measurement, and for O2 utilized in glucose oxidase catalyze reaction in substrate over the second O2 electrode. Now this is all about the blood glucose biosensors. Thank you.